This is the solution to problem 41 from homework 7.2. In the first part, we're asked to use a graphing utility to determine whether the equation is an identity. This isn't a true verification, but it's a way to check. And you can see here I have pasted in a picture from my graphing calculator where I made f1 of x equal to the left-hand side of the equation. And we can see that the graph that comes out is the same thing as the line f of x equals 1. So that shows us that this identity should be true, but we need to verify it algebraically. So to do that, I have 4 terms, and I'm going to try a technique which would be to factor by grouping. So I'm going to take the greatest common factor out from the first 2 terms. That greatest common factor is 2 secant squared x. When I pull that out, that leaves me with 1 minus sine squared x. And the last 2 terms I can factor out a negative 1. So I have negative 1 times sine squared x plus cosine squared x. When I see 1 minus sine squared x here, I should be thinking about the Pythagorean identity, which is sine squared x plus cosine squared x equals 1. Subtracting sine squared x from both sides of the equation, we can see that cosine squared x is 1 minus sine squared x, and I can make that substitution right here. So instead of 1 minus sine squared x, I'm going to write cosine squared x, so that's going to leave me with 2 secant squared x times cosine squared x minus sine squared x plus cosine squared x. That's a Pythagorean identity, and that's just 1, so I have minus 1. Secant squared x I'm going to rewrite as 1 over cosine squared x using the reciprocal identity. And then I have 1 over cosine squared x times cosine squared x over 1 minus 1. The cosine squared x here cancel out. So this becomes 2 minus 1, which is equal to 1. And we have verified this identity.